Hello everyone, this is a continuation video for chapter 4, which is for loops and while loops. If you did not watch previous videos, please go back and do that. I will quickly remind you what is a sentinel. If you remember, last time I published videos, there was an example in the same week. There was an example that where we computed a total. So user was inputting numbers and we were to compute a total. That is one important example. And the sentinel there was 0. So if user enters 0, we don't really need to add 0. And that means we should stop adding, we should exit our program and display the total. So that is a quick reminder of what is a sentinel. And with the use of Sentinel can be very helpful. Input validation loops. The problem is that when you program, you have to make contingencies for bad input. For example, you ask somebody to enter a number 5, and you would expect something like a number 5, but instead a person enters the word 5 or just enters some gibberish. Or alternatively, you're asking a person, how many hours did you study yesterday? And the person answers 100 hours, which is not realistic. So if a user provides bad input, it's better to handle it and let the user know that this is not what the program is designed for, and otherwise the program will run, produce bad output, and the user will be clueless about the fact that the output is bad. We cannot assume that the user is competent or he knows what's going on under the hood of our program. So this is a principle. You go garbage in, garbage out. If you give bad input, it produces bad output unless it is handled otherwise. So we want a program that where bad input is never accepted. So whenever you are asking for input, it's a good style to inspect whether this is good input and only then process it by the program. This is usually accomplished with a while loop, which repeats as long as input is bad. Keep asking the same question, like saying this is bad input and asking a question again. If the input is good, continue to process the input. So this would be a general logic for input validation loop. Get input, have some kind of condition checking that the input is bad. In our case, it will be checking that the answer is less than 24 hours because there is only 24 hours in a day and only those answers would make sense. Yes, if input is bad, then display the error message and get the input again and loop back into checking whether input is bad. Otherwise, do the rest of your program and your input is good. It is not very easy to describe what is bad input, what the user can do potentially to create bad inputs. It is sometimes a challenge in itself. We also don't quite know all the tools to do that, but at least we will be able to weed out bad numbers and keep good numbers, or weed out bad strings and keep good strings. Further on, we will see some other tools that will be helpful to basically deal with any input and any error that this input generates. I'm talking about try except, of course, but that is later in the course. All right, so let me go to an example that I was preparing. This is a program input validation. We want to write a program that asks someone how many hours did the person study yesterday. If the answer is over 24, say incorrect input and ask again. So the person is not telling the truth. And if the answer is less than 24 hours, kind of accept the answer and maybe say if you studied more than 2 hours, that's cool. Okay, so that's what we will do. So I will need a while loop. I'll say while num greater than 24. Num is a variable while the user input is greater than 24. I will say, let me think real quick of the best order to do that. This, yeah, I will print that cannot be true. And then ask for the num value again. Num value will be float input how many hours did you study yesterday. Okay, so while the number is bigger than 24, this is what we will do. And after the person provides an answer that is less than 24 hours, we'll do an if case. If number is greater than 2, print you work hard or you study hard. Else, just say something vaguely positive. Cool. All right, so as I was typing this up, I'm sure you came up with a criticism, the part that does not work here, if you did not pause and think what we will need to do. And of course, we will need to prime the variable num, give it some value before we're checking that it's bigger than 24, otherwise we are running into an error. Okay, so let me just copy this line. I think that will work nicely. And I think we're done. So run module, find all your errors, unindent does not match. So somehow I did a blank space and that probably shifted this as well. Okay, let's try again. How many hours did you study? 30. That cannot be true. How many hours did you study? 100. That cannot be true. And finally, 3. You study hard. Okay. That was input validation loop. So before we were going to give any praise, we decided to include an while loop, the input validation loop that basically checks that the number is somewhat realistic. So of course we don't know if the number is less than 24 hours, whether that is a true number or not, but that gives at least some cutoff for unrealistic inputs, which is the goal of this program. By the way, on the subject of how to study, it's important to practice. It's important to read code from our book. Here is our book in case you need to see it. This is some of the base chapters. If you do well and you practice hard here, it will help you later in the course because everything that we touched in this chapter will be useful, at least from time to time, if not all the time. There won't be any chapter where you would need not need to use a for loop or while loop. There won't be any chapter where you wouldn't be using if else. So that is universally very useful, very basic pieces of code, and you need to practice, practice, and more practice. Which is pretty much the point of this video. By the way, how to practice for all the introductory level classes or activities if you want to learn something. Half an hour a day goes much better than, say, 8 hours on Friday or 8 hours on Saturday. All right, so let us move on to the next example, and I need to maybe show you a couple of slides of nested loops. Here is maybe an example that I like. So what is nested loops? So loop is that is contained inside another loop. I encourage you to look through this example and study this little nested loop. So it nests first hours, then sorry, excuse me, I'm sliding. It nests first it cycles through hours, then inside every hour it cycles through minutes, and then it cycles through seconds. So that is an interesting thing and also very useful and widely used pattern, a loop inside a loop. And for a nested loop, a number of outer iterations times number of inner iterations is how many times this program will, the innermost piece of code will run. So let me show you a different example. Okay, we will use nested loops to print some nice pattern. So something like a triangular pattern, or maybe in the inverse order. So let us do some printing with loops. So for now, let's make n equals to 5. I'm gonna do a for loop for m in range 1, does not really matter, range n. And inside it, I'm gonna start another loop for k in range m, and start thinking what this means. So the variable m over here is the same as this variable m, and inside I do a print. I print one sharp symbol, and then I say that the separator is nothing, and also end of the line is nothing. And on this level, I will do a print and let's keep the print empty. So think how many times will this run, considering that in this case the inside loop depends on the parameter of the outside loop. And how would you count that? So let's think about the outer loop. M in range n, in range capital N. So n is 5, so m will take values 0, 1, 2, 3, 4. For k in range m, so first time around m equals 0, so there is no range, it won't work at all, actually, now that I think about it. Second time m equals to 1, so range 1 consists only of 0, so range 1 for k in range 1, that is just number 0, this will work only once. We will print a sharp symbol with no separator and no end, and then empty print will create a new line. So that way, when m equals to 1, we will create one sharp symbol. Now the next m is 2. Range 2, sorry, m in 2 is in m equals 2, that is in range 5. K in range 2, the k values will be 0 and 1. For each of this value, we will print sharp symbol again with separate their empty string and empty string. This will print this. And then the empty print statement will just do the new line, because an empty print statement by default end of the line is new line. Okay, let's see if it prints exactly what I wanted to print. And the answer is no, but we'll take care of that. Unindent over here. Oh, okay, now it will work. Indentations are important. Let's see, so I printed 4. Why did that happen? Let's think this through carefully. M in range n, the upper limit for the range, and if you forgot what that is, please do look back at the discussion of the range function that I did in an earlier video. This is very important. Range 5 will produce values from 0 to 4, so the last one, k, will be, the last value m will be 4. Range 4 will consist of 0, 1, 2, 3. In any case, that is 4 values only, and this is going to be printed 4 times. To compensate, let me actually put +1 over here. Run. So it's almost what we want. The first print is 0. I don't want that, so I'm gonna add 1 over here. So starting value is 1, and it will finish at n at value 5. So the last value m will be 5, because this is the upper limit, 5 plus 1. Okay. Let me resize this, okay, so this is the last printout, and it does exactly what we wanted it to do. So print sharp symbols from 1 to 5. Now we can make it interesting, so I will just say int input enter n. So we want to do this for any number n. To make it a little bit more interesting and interactive, let me close the idle so that we start a new one. Okay, apologies, parentheses closed. Yeah, that is normal, little debugging. So enter n, my n will be 7. Here we go. It creates this triangle of sharp symbols from 1 to 7. That's cool. So now how about we reverse the order of triangles? And I will do a reverse. How do we reverse this? We are going to reverse one of the ranges. So first time I will need n triangles. So I will start, my starting value will be n. My ending value will be, limiting value will be 0, and my increment will be -1. And I don't do anything with the inner loop, because if you think about it, all it does, this piece of a code, it repeatedly print sharp symbol as many times as range m actually prescribes, so the value m times. All right, let's do this and try enter n. My n will be 5. All right, so it did it in opposite order. So we could do something like diamond shapes over here, or we can play around with it a little more. So try to make a diamond shape. If you can make a diamond shape, that means you understand this completely. All right, let us move to other examples. So the rest of, I think I pretty much finished with the lectures. There are some turtle graphics that we will do. Actually, let's do it right now. So here is how you create a square in a turtle efficiently with a turtle. So for x in range 4, it doesn't really matter. This x doesn't really matter. It has to be there to count, but it's not really used inside. So you can notice that for programs where the value of this so-called target variable x will be used inside, look back at some of our earlier examples, for example. And we will have an example like that again for a factorial. So turtle forward 100, that creates a side, and then turtle right 90 degrees, so turn right 90 degrees and turn right 90 degrees, so the turtle is turning right and goes around a rectangle. There is 4 sides, so this will be implemented 4 times. This code will be repeated 4 times. And that's where we will start, and then we will create something slightly more general, for example, octagon. If x in range 8, so we need 8 sides now, turtle forward 100, and the angle is twice smaller. Think of it as we go around like this. It's called actually in mathematics outer angle. The outer angle should altogether make 360 degrees. So 45 times 8 is 360. Okay, let us actually look at the program. Where is my draw a polygon program? So when working with turtle, the first line is import turtle, and I'm going to do the octagon first for n in range. I'm gonna call it capital N for future purposes, and for now my n is just 8. For in range n, so turtle forward. Maybe I'll make a slightly smaller side, for example 40, and turtle right 45. So this is a number in degrees, and this is a length in pixels in turtle. Let's make sure it actually works. Yeah, the turtle kind of runs around, and the turtle is really a triangle, as you know. It's a little small for my eye, so let me make it 60. Also, let's slow down the turtle. Turtle dot speed 1. And if you are bothered with a turtle, we can hide it. After it's done running around, we could do it at any time. Turtle hide, and then I think that's how it's done, but we'll see. So it's drawing octagon slower. For some reason the turtle did not hide, so that is interesting. Well, I think it does not really matter. So what I want to do, I could actually go and look at the turtle documentation online. So if I go and do turtle, actually maybe I want to do that. Python turtle hide. Well, there is a Stack Overflow question, hide turtle. Okay. Or HT. All right, that I can do. Where is my program? Draw polygon, turtle hide ht hide. Okay, let's see if it will hide. Okay, for some reason I did not do indentation right. So it draws slowly so that we can see everything, and then it hides. Okay, good turtle. Now I want to draw an n-gon. That is, I want a user to enter the number of sides and then the turtle drawing that. So to achieve that, instead of 45, which is 360 by 8, I should do 360 by n. Actually, n, and I'm gonna do an int here, because if I just divide, it may be a fractional value, and we don't want that. Or maybe it's okay. Actually, maybe it's okay. I don't want to round because then it won't look as nice. Okay, so cancel, and it still runs the same with 8, just the same because I did not ask the user to enter a value here. But at least we did not spoil anything, so this should be int from input enter number of sides for the polygon. All right, let's run. That's an error. Enter the number of sides for no error 10, for example. Where is my polygon? Oh, okay, so it was underneath. Okay, so there is 10 sides here, and all is well. For example, we can rerun it. Maybe make it smaller. I need it to be much smaller. So number of sides of the polygon, how about we do 15 gon? So let's see how it generates. Where is it generating? Here it is. Okay, yeah. It's generating the polygon, but my polygon does not fit now. Oh no, it does. It's just not full screen. Okay, so here is my 15 gon. You can barely distinguish it from a circle. That's the problem. If we make it bigger, first of all, they are going to reach the end of the field. They are going to grow too large, and also they are going to look pretty much like a circle. All right, so that was a little pattern with the turtle, and feel free to go on, and in the book there are some interesting patterns with circles, some design patterns, and that is fun. Okay,